Okay, hey, hello. So it's 9 o'clock, so I'm going to start today's Houdini tutorial. Hello. So today the theme today is to create a geometry like this shown in the display right now. Kind of interesting sculpture shape, which is also parametric. You can control this shape using some parameters that I set. And it's all continuous. If you look at it from inside, it's like a knotted surface. It means you can 3D print it as one object, which could be really interesting. And you can try out many different variety of shapes by changing those parameters. And the original idea came from a work of Bathsheba sculpture website. And this website shows several interesting artworks, which is creating really interesting geometrical sculptures based on a really simple geometric deformation, I think. And this is the one that I have chose today as a topic. Now this itself is a fixed shapes, so I wanted to make it more parametric, so that I can try out many kinds of shape using the same rule being underneath it. So that's what I'm going to explain here today. So in order to make it parametric, I guess it's easy to create this kind of form manually, like using Blender or Maya. But if you want to do it procedurally using Houdini, then you have to know the rule underneath in order to create the rule for the composition. So before getting into actual writing in the Houdini, I have just pasted the image from the website to the Photoshop and start explaining what kind of rules I could find from this image in order to think about how to set up the parameters for this object, for this kind of shape. So if you look at the shape carefully, I could notice some characteristics. One is this kind of star shape, which have Pentagon-like shape facing. Okay, I cannot seem to write. Right. So I see those pentagons. I'm gonna make the size of the eraser bigger. I see some pentagons on top of this star shape, like this. And I can see that from each of the edge of the pentagon, some kind of tentacle is being released or being created like this. And you can barely see underneath this because this is being hidden by another tentacle, but from what I could imagine, I think those three tentacles are being connected like this. See this? So the one underneath have three connection for each tentacles being created from each edge of the pentagon. And this three-edge shape could be constructed using some kind of hexagon shape as a core. So you can ignore these edges, but just use those three edges to connect with each edge on the pentagon to create a shape like this. So this is kind of one element in order to create this whole shape. So if you continue creating this set in a rotational manner, then I guess you'll be able to create the whole shape. So other tentacles should be connecting with other tentacles, like here, from here, or if it's coming from here, maybe connecting with these tentacles. So that means that if you could create one pair of this shape, then you'll be able to create other tentacles as well, because this is pretty much symmetrical shape. And let me show how I could do this using Houdini. Right. Okay, so as you can see, the element that I see right now from the image is set of pentagons and set of hexagons. So I guess I should start from these shapes, having pentagons projected on the ball and also hexagon projected on a smaller ball. To do that, one of the easiest way I find out is to use the node, what was it? Let me just bring this up. Okay, so one of the easiest way to create that for a base shape is to use a platonic node. Inside a platonic node, there is one node which have both hexagon and pentagon, creating a ball-like shape, which is this fifth or sixth shape called sucker ball. If you choose that, it actually contains both hexagon and pentagon, creating a ball. Well, currently the edge of each pentagon and hexagon are connected, but we can separate that later on. So I thought I could use this as a base shape, in order to create this kind of composition. Right, so let's do that. Before doing that, I want to be able to evaluate which one is pentagon and which one is hexagon. So let's put a group to those two types of polygons. Okay, what's this? I'm gonna do this using primitive wrangle. Okay, I'm gonna name this group. And one way to determine if it's hexagon or Pentagon is to check the number of vertices for each primitives, or for this one, since this is a soccer ball and it has a primitive color for each meshes, I could also use color to separate each meshes. So in the example I have posted, which you can download in the description, you can it is using the color information, so I'm going to use the color for this example. But you can also check the number of vertices for each primitives as well. Okay, so if the color, I'll just look at the red value, is less than 0.5, then it means it could be a black color. So let's set this primitive to Pentagon. So set prim group Pentagon prim num1. Else it should be Hexagon. Right, so let's check if the separation goes correctly. I'm gonna check it by using delete and set the group to, like, say Hexagon, and it is not deleting, so I guess it's wrong. Okay, let's see what's wrong here. Okay, so if cd, let me check out the geometry spreadsheet and the primitive wrangle, and okay, value wise it is separated, so seems like the result of this delete is kind of wrong. Maybe there's a cache. Right, okay, now it works. Okay, so the grouping went well. The next thing I would like to do is to separate those two meshes, but what I want to have is this tentacle information. So if you hide the underneath image, it looks like this, and let me also redraw this with new color. So the element, the important element you want to have is this hexagon, one of the pentagon and the hexagon. Connected with this curvy tentacles. Okay, let's hide the red one. See this? So in order to create this kind of composition, you want to have each pentagon and hexagon separated, and at the same time you want each of the pentagon edges to be connected with one of the edges on the hexagon with in-between shape like this. So I want to create a base composition in order to create something like this, and to do that I'm going to do something like this. From the soccer ball, let me bring this up a little bit. From the soccer ball, I have this hexagon and pentagon and hexagon and another pentagon like this. So right now it's being connected, directly connected, but I want to have some in-between mesh between those two connections. So to do that, I'm going to offset this hexagon inward, something like this. and then create a mesh like this to connect with the pentagon next to the hexagon, and remove those meshes which is not connected with the pentagon. So as a result, you will have a mesh looking like this. So this part will going to be the base mesh for this tentacle. And later on, I'm going to apply some rotation, some deformations in order to make it more curvy. So let's do that by first offsetting the hexagon inward. To do that, I'm going to use poly extrude, and only apply to the hexagon, only work on the hexagon. Then also check this individual elements on. So by doing that, you can, if you control this, if you change this inset value, you can offset the edge of the hexagon inward or outward. But in this case, I want to make it inward. Right? So you can control how much the shape, how much the size of this hexagon should be by changing those parameters, changing these parameters. So I am going to, so that this parameter could be a really important parameter in order to change the shape itself for later on. So I'm going to create a null parameter to store this parameter so that you can access to it later on. Direct access to this parameter. And let's name this hexagon offset. Right, and I'm going to set the range between 0 to 0.35 or something. Right. Okay, and let's copy this parameter and then paste it right here. Paste relative reference like this. Now you're able to control and those inset parameters. Now next thing you want to do is to delete those meshes which is not touching with pentagon. You only want the offsetted mesh which is touching with this pentagon, as I explained this in this sketch. So let's do that by I'm just gonna use another primitive wrangle to do that. And also I would like to be able to rotate this hexagon itself at the same time, because right now if the angle is at as this is, you see that the part that should be pentacle is too straight. So in order to make it more twisted, you want to rotate this hexagon shape clockwise or counterclockwise, either way. When you do that, if you rotate this like 60 degrees, the shape itself doesn't seem to change, but the position of the tentacle changes. So in this case, this could go right here, this could go right here, go right here by just rotating this hexagon. And you could also have more twist by rotating this pentagon as well, using this center point as an axis. But I could do that later on. For this time, I'm just going to rotate this hexagon in order to make a twist. At the same time, I am also going to delete those unnecessary edge meshes. So let's do that by using a primitive wrangle, writing some code. Okay. And to do that, to write a code, I need some cheat sheet so that I can look at it. Let me open the file. Sorry for that, just force quit. Okay. Alright, so let's give primitive wrangle. I'm gonna name this hex rotation. Okay, and let's let's first check these meshes where you want to delete. So in order to find those meshes, I need to have some conditions where to how to filter this primitive when using the primitive wrangle. So for as the starting point, I think it might be a good idea to start with this center hexagon, then look at the neighbors and look at another neighbors from the one that you have found. Then if the neighbor of the neighbor is Pentagon, then you can keep the edge mesh. If the neighbor of the neighbor is not Pentagon, not equal to Pentagon, then you can delete that first neighbor. So that could be a good rule. So let's do that. So if you want to start with, if you want to calculate based on just on those center hexagon, then you need to have some group attached only on this center hexagon, offset hexagon. You can have that kind of group by going back to the poly extrude and go underneath and check this front group, extrude front group, and also let's also check this extrude side group. So after checking this, I think the extrude front group is corresponding to this center hexagon. Let's check that by using the delete node. Okay, let's save this file so that I won't lose the file. Okay, let's name this not. I'm gonna use this delete to check if the filtering is working by checking it to extrude front, delete non-selected. Okay, maybe there's another cache here. Let's go back on top and go back. Yeah, only the center hexagon has been retrieved, so I think this filtering is correct. So I only want to calculate for this center hexagon, so I'm gonna select to this extrude front. Then first thing I would like to do is to find out the neighbor primitive, and I can find out that by using a function called polyneighbors. At selected primitive numbers. Right, and I'm gonna look through all the primitives that I have found, which is the neighbor of this center hexagon. So that should be either this one, this one, this one, this one, this one, this one. So in total, there should always be 6 neighbors. Okay, let's retrieve the primitive numbers from the array. Now, for each neighbors, I would like to find another neighbor primitives. So for this one, I want to find out the neighbor of this one. So that could be this pentagon, or this side squares, or this side squares. For this one, that could be this square, or this square. Now, from that neighbors, if one of the neighbor primitive is equal to pentagon, is inside a pentagon group, then you want to keep that mesh. You want to keep this mesh. But if you couldn't find a pentagon as a neighbor, then you want to delete this mesh. So that's the rule that I want to set up here. So to do that, I'm going to create another primitive. I'm going to call another primitive neighbors, polyneighbors. I'm gonna name this primneighbors, polyneighbors at prim, and another for loop. And let's get the number of neighbors from the array. Okay, and next thing I would like to do is to check whether this primitive is inside the pentagon group or not. So I'm going to use a function called imprimGroup if the primitive number is inside the specific group. And this time I'm going to check if this is in the pentagon group. Alright, so if this is 1 equal to 1, then which means it is inside the pentagon group, so you want to keep that. If it's not, then you want to remove that. So if is pentagon is equal to 0, then you want to remove this. Now you are looping through all the neighbors here, so you can just exit the for each or for loop if you just find out one of the geometry, one of the pentagon, one of the, well, in this case I guess I need to check whether if there is a pentagon or not. So I should say something like this, because there could be a way that everything is 0, everything is equal to 0. So I'm going to set a condition like this. So if you find out that there is a pentagon, then you want to keep the mesh. So let's also create a flag just before the for loop, something like remove, and let's set it to 1. So if the remove flag is equal to 1, then I want to remove it. But as soon as you find out that there is a pentagon on the neighbors, then you want to set the remove to 0, then exit the loop. Right? And then after exiting the loop, if you find out that the remove flag is equal to 1, which means if you couldn't find a pentagon, then remove the prim. Like this, and if you check the result, it seems to work just fine. Yeah, so this is the basic setup, which is this one. Yeah. And that seems to work well. So the next thing I would like to do is to rotate the center hexagon, either clockwise or counterclockwise, either way. So let's do that. Let's do that by, let's say, outside this for loop. Maybe I could do that in another primitive wrangle, since it might be too complicated for one node, although it could be faster. Well, let's just do it in one node, since in the example I'm doing in one node. So let's make it the same. Right. I've opened the code editor, and in order to access this center hexagon, I'm already filtering this primitive wrangle with the extrude front. So what I just need to do is to get the point list of each primitive using prim points, and then use the for loop to walk through all the points and rotate each vertex of this primitive using this center of this hexagon as an axis. I also need the direction of the axis, so I can retrieve that from the normal direction of the surface, but I am not sure if I have any primitive normal at this moment, so let's check that. If you look at the primitive geometry spreadsheet of the primitive attribute, I don't see any normal information, so let's add that information before using the primitive wrangle, and set the normal node to primitive, which should create a surface normal like this, right? And if you look at the geometry spreadsheet, and for the primitive attribute, you could see those normal attribute for each primitive, and I will going to use those as a rotation axis. Okay, let's go back to the code. Now let's retrieve the position of each point. Using point function. And in order to rotate the point using a code, I need to either create a quaternion or matrix, rotation matrix. I tend to make a rotation matrix, so I'm gonna start by creating a ident matrix, then rotate this matrix using an angle. For example, like I did in this sketch, I'm just going to rotate with the constant value. Maybe I could parameterize it later on, but for testing out, I'm going to rotate by 60 degrees. Okay, and for a rotational axis, I'm going to use a normal for the hexagon, for the primitive, right? Now I have created the rotational matrix. I would like to rotate each hexagon vertex from the center, using this center as an axis, rotational center. To do that, I need to first move whole points constructing the hexagon by the center position of this hexagon. So center hexagon, center of the hexagon can be retrieved by @p for the primitive. Then I'm going to rotate this using matrix, rotational matrix that I've created. Then add the center point position again with @p. Alright, let's see. And I am okay. So after you have created this new position, I need to set this position vector to a actual point as a point information. So I'm going to set call a set point attribute in order to update the current point position with newly created attribute vector variable. Right, so I guess it seemed to work. If I change this to 30, if I change this to 0, yeah, I think it's working. Now I might want to parameterize this value so that I could I could control the twistiness later on. I could either use like threshold value from 0 to 1 or direct value like an angle like 60 degrees or 120 degrees. Either way is fine, I guess, but I'm going to, in the example I'm using a threshold value, but in this case I'm gonna use the actual angle value so that I could also use like a negative value as well. So let's create a parameter called ang using CHF, apply, accept, promote the parameter, and let's set the maximum and negative value of this angle to from -120 to 120 degrees. Okay, so when I change this, I'll be able to twist this in either direction, right? 60 should be a default value, though. This is the most clean parameter from what I have tested. Okay, let's have this promoted inside the node controller as well. Let's open up the node. Let's go back to the node controller, open up the edit parameter interface. Let's check off this 4-bit linking parameters from outside the subnet. Then go back to the hex, rotation, primitive angle, then drag and drop this angle parameter here. And let's rename this to hexagon rotation angle. Okay. And check if it still works by changing these parameters inside this node controller. Okay, seems to work. Looks good. Now, as you can see, this is kind of twisted, but there are some problems here. I might also want to rotate this pentagon as well, maybe to clockwise for this one, to make it more like a shape like this. So currently twisting is like this, but in order to create this kind of arc-like shape, you want to also rotate this pentagon. Okay, so let's do that, but I also would like to create some setup for the in-between mesh, which is this one, because right now this is just a straight line, as you can see, but in the end I want to make it as an arc like this. And to create an arc like this, you need to have a point, a several number of points which divides the in-between line. Currently it is like a straight line which only have 2 points to create a line, but you don't want that. The actual stuff you want is this kind of curvy shape. So in order to do that, you need to have those number of points, but I could make that from the lines actually, using a resample node later on. So what I want to do here is to just create a 2 lines which connects the edge, which is for this one, this edge, and this edge. And actually I don't really need the mesh in between for now. The process that I want to do here is something like this. So first, let's say you have Pentagon and Hexagon, and a line like this, and you just want to extract the outer line, which is this one and this one, this blue line. Then later on I want to resample this, or after retrieving this, I want to rotate this pentagon as well to, say, clockwise by 360 divided by 5, which by rotating with this degree you don't see any changes in this shape itself, but you see the changes of this connection, which this one goes to here, this one goes to here. So in the end, you will see this kind of edge connection. And then after having this, I can finally resample this blue line using some resample node or something. Then after resampling it, I could deform this each line using some kind of force vector, something like this, and then create a mesh using a node like loft or skin. Okay, I have a question. Is this more of a Vex tutorial? Yes, it is. It is a Vex tutorial. All the things that I do is contains a lot of Vex coding, so yeah, I guess this is not for basic, but the idea is like this. I guess you could do the same thing without using Vex. Well, you could definitely do that using VOP network, but without it, I'm not sure. by just using node network without VOP, even the VOP network, then maybe it's not possible. In my case, I use Vex. I like using Vex, so that's why I'm doing it. That's why I'm using it a lot, and it's kind of a good practice for me as well. Right. So that was the idea, what I wanted to do. So let's try to extract the side lines from this in between mesh which connects the hexagon and pentagon. Okay, so to do that, I need to find out which one is this mesh inside this code. And that is easy to find. That is where I have set the condition right here. If the remove is equal to 1, then that was the one that is not touching the pentagon. But if the remove is equal to 0, then that's the one that is touching the pentagon, and which is this one, the one that I want to extract the line from. So let's do that. In order to extract the lines, I need to have the point information for those 4 corners. So let's retrieve that using PTS prim points. Okay. And so I know that the condition remove equal to 0 always have 4 points in this case. So I could guess that there is 4 exact point, which could be, this one could be PT 1 1, this could be PT 1 2, this could be PT 2 2, this could be PT 2 1 or something. So let's guess that these are the, or maybe these one, the PT 1 1 and PT 1 2. Let's say the point which is touching to the pentagon is starting with PT 1, and the point which is touching the hexagon starts with PT 2. So PT 1 1, let's say this is the PT 1 1. This is just a guessing. I will going to check that by actually creating a line, and if it's opposite, then I will just switch the order later on. And let's guess that this PT1 2 is this one, so PTS 1, and PT 2 1 PTS. PT 2 1 should be, I want this to be PT 2 1, and since the point order is always going, maybe not always, but most of the time going clockwise or counterclockwise by the vertex order. So let's guess that this is the number 3, the index 3 for the PT21, which is this one. And PT22, PT. So this one should be index 2. Well, this is just guessing. If it's wrong, then I'm gonna change it later on. Now let's try to create a line from the PT11 and PT21, also PT11 and PT12 and the PT22. So let's create a line 1, add prim poly line pt21, pt11, pt21, int line 2 add prim pt12, pt22. Okay, let's see. Now it's a bit hard to see where the line has been created, so let's remove the mesh itself. So let's remove prim. Okay, and I think the position was correct. So I have successfully extracted the line which is on the edge of these connecting primitive like this. Now later on I want to connect those two lines together using like a skin node or loft node, polyloft node, in order to create a continuous mesh, in order to reconstruct a smooth mesh. So I need to have some kind of identifier to know that these are the pairs which should be connected. So let's set some ID for each line which should have same ID. Let's do that by set prim attribute ID. For line 1 I'm going to set prim, and I'm going to set the same ID to line 2 with this prim. Alright, and let's also set the group for these lines that I have created so that I can filter these later on. So set prim group, I'll just name it as line, and same for the line 2. Okay, now there is another information I want to have for each for those lines that I have created, which is, if I go back to the sketch, which is this force information. You see that when the line is created like this, I want to move those lines, deform this line to the outer direction, which is from the center line. Let's say that the center of each pentagon and hexagon being connected by line, and take the middle point and from this middle point to the those points I want to move those points with the direction from this center point, so that I could create an arc like this. It could be like parallel direction, it could be like a omnidirectional force, either way. But in order to do that, you need to have some kind of center point where the force starts. And for this things, I thought it would be a good idea to get the center point of the line which connects the center of pentagon and hexagon. So let's retrieve this center information and add it as a primitive attribute to each line. Okay, so the calculation is pretty simple, I think. You need to first calculate the center position, which is between the center of hexagon, which you can retrieve by accessing to at p in this primitive wrangle, and the the center of this pentagon. Right now I don't have it, so let's retrieve that using pentapos. Well, I'll just call pentap equal to prim 0 position at primitive pentagon number. So right now I don't have a pentagon number here. I don't know which number this one is, so I have to find out. And you could kind of get that inside this condition. So this condition is activated when you find out that there is a pentagon. So this is a good position where in order to retrieve the pentagon number of the neighbors. So let's have a variable called pentanum starting from -1, and when you find out the pentagon, then update the pentanum with the this value, which is equal to pentagon number. The neighbor of this connected mesh. So I'm checking if this mesh is pentagon or not using this function. So if you find out that this is the pentagon, then this prim neighbor number is equal to the number of the pentagon. So that's the rule. Now I have retrieved the pentanum. I can retrieve the center point of this pentagon using this function. And then after retrieving this pentagon center position, I can add with the center of the hexagon, then divide those by 2 or multiply by 0.5 to get the center. Alright. Now I have retrieved the center point in between those two hexagon and pentagon. I'm going to add this as a primitive attribute to each line, which later I'm going to use it as a center point for the force. Okay. Something like this. Okay, let's see. Okay, I have error. Right, let's see where that is. Using initialized reference to undefined variable pemp. Okay, where is that? Okay, this one should be pentap, right? Now let's check out the geometry spreadsheet, going to the primitive, and if I have necessary attributes created. So I have line group. Okay, it's activated. Let's also check the ID. Yeah, I see IDs being created as well for lines, group lines, so that should also be correct. And also the center information, so that also seems to correct. Okay, now that I have necessary information, let's rotate the pentagon next. So this one. And for this one, I guess I want to rotate clockwise for each of them. Maybe rotating this 360 divided by 5 or somewhere around that. Okay. So to do that, I need to create another primitive wrangle. then this time I'm going to filter this with the group Pentagon, since I only want to rotate Pentagon in this case. So I'm gonna name pen rotation. Okay. Right. Another rotational code. It's pretty much similar to what I did in Hexagon, hex rotation. What I'm gonna do first is to get the whole point list of points from the primitive. So using prim points. Okay, and use the for loop to loop through all the points. Get the point information from the point position information. Right. Now make a rotational matrix, starting by creating a ident matrix. Then rotate this matrix value by some kind of angle, and I might want to control that using some parameters as well, but for now let's keep it constant for testing. So in order to rotate clockwise, I think I need to make it negative, so 360 degrees divided by 5. Okay, and for the axis I'm going to use a normal for the primitive. Okay, and same procedures as before. In order to rotate each position, first I'm going to move whole points by to the negative position of the center point, like this, center point of this hexagon, which should be the rotation center of this transformation. Then multiply this position by matrix so that in order to actually rotate using this matrix, then add point position again. Okay, and then I also need to update the point position using set point attribute at pt using point position. Okay, now the shape didn't change itself, but as you can see, the connection line, the position of the connection line have been changed. It's let's change this gradually so that you can see that it actually is changing. So if I change this to 8, see that the hexagon have been rotated. I change to 7. Yeah, gradually it is rotating, and finally if it's equal to 5, rotate it like this. Okay, so I might want to be able to control this as well, so let's give a parameter for this as well. Let's say CHF pen rot penang. Okay, and promote this parameter. Let's set the range between, I don't know, maybe 120 to 120 again. Okay, Okay, I'm gonna set the default value to -72, which is equal to 360 divided by 5. Okay, and let's also have this parameter inside this null controller. Go back, uncheck for bit linking parameters, then drag and drop this rotational value for the Pentagon. And let's rename this Pentagon rotation angle. Okay. Right. Looks good so far, I think. Now, next thing I would like to do is to move those points, resample those lines, then create a curvy surface like this. So let's do that. Okay, and I can do that. I'm going to do that after this using resample. But I guess it's in this time, I guess it's a good idea to separate those lines and meshes to different node. So I'm going to use a split node so that I can only get those lines that I want to modify, and those lines have a group called line that I have created inside a primitive wrangles. So by checking the line, I should be able to get only the line geometry. And I'm not, okay, maybe I have to go back again. Okay, so these are the lines that I want to modify. Okay, and currently, if you look at it, there's only 2 points constructing one line. So that's where you want to apply resample to add more lines in between, so that you can make those curves more curvy, more smoothly deformed. Okay, you don't want to use the segment lengths for the resample, but instead you want to check this maximum segments value here. And let's set it to low value for now, because later on I'm going to use a subdivide node in order to make it more detailed. So I should make this number, max segments number, to be low as possible, and I found out that 5 or 6 is a good kind of a good number. So I'm gonna keep it as a 5 as a constant number here. Maybe you want to if you want, you can parameterize this as well, I guess. Now after I have resampled the line, next thing I would like to do is to actually deform those lines using the information called center here. Right, let's do that. So center is the center position. So using this center, I'm going to create a force value in order to deform each line to a specific direction, then actually create a arch-like curve. So let's do that using point wrangle this time. And I'm gonna name this ring offset. Okay. Now for these, I don't need to filter this wrangle, although I think I might be a good idea to set it as primitive instead of points, so that I can access to each primitive as one line, and I can access to the points which contains inside this line, inside each line. And also, in order to create an arch-like shape, I want to avoid moving the endpoint of the line to make it like an arch. I want to move farther away. I want to move those points which is close to the center of the line farther away from the center. And when it gets close to the end point of the line, then I want to avoid moving those lines to make it like an arch. Okay, to do that, one of the way I could think of is to first promote the attribute called curve U using resample, which creates an attribute called curve U in each point, each resampled point from the line. So for each line, you have a curve U attribute starting from the starting point of the line and to the end point of the line, starting from 0 to 1. So if the starting point is 0, then the end point, the curve U value of the end point is 1, and in between it should be something like 0.2, 0.4, 0.6, 0.8 or something like that. So it's always like a 0 to 1 value, parameter value, which shows the address of the point. So this is really useful. Okay, having those attributes on each point, set the wrangle to primitive, then let's write some code to actually deform those lines. Okay, let's first access to all the points, constructing this line using prim points, which I've been using a lot in this tutorial. Okay, and walk through all the points using for loop. Okay. Like this, and let's also get the point position using point function as I did it before. Okay, and let's also access to the curve U value, and I'm gonna name it as T. For each point, curve U. Okay, now from curve U, I want to create some kind of arch-like shape. So let's think about how to create that. So if I have a line like this, and the T starts from 0, and that's 1, and in between you have like 0.2, 0.4, 0.6, 0.8, and so on. So these are like linear increasing value. In order to make it like this kind of curve instead of like continuously increasing value, there are several ways, but the easiest way that I could think of is to use this value, the one goes from 0 to 1, convert it into an angle for the sine wave. So the sine wave is like this. And if the angle is 0, then the position is right here. And if the angle is equal to pi, which is equal to 180 degrees, you have another point which is the end point of this mountain. So from 0 to pi, you could retrieve this kind of mountain-like shape. So by converting this value from 0 to 180 and use it as a sine angle, then I could have this kind of arch-like shape. So that's what I'm gonna do. I have t, which is from 0 to 1, so let's create an angle by multiplying this t by pi. So if the t is equal to 0, then it will become 0. If t is equal to 1, then it will become pi. And create a value using sine with this angle. And as a result, you'll be able to have a value goes from 0 to 1 and go back to 0, creating this arch-like shape. Okay. Now, there's one thing I would like to set at this point, which is clamp. The clamp is to trim the value which is below the minimum and above the maximum. Just in case I want to set this sine values range in between 0 to 1, so just in case I'm going to use clamp to limit the value from 0 to 1. I might not need this, but just in case. Alright. Now that I have this arch-like value which goes from 0 to 1, let's use this in order to actually move the point position. Then the next thing I need to have is the direction where the point should move. Now last time I have created a center point for each line, so let's retrieve that first. You can retrieve the center point by accessing to the center attribute of the primitive, so you can access just like this. Okay, now let's create a direction where you want to move the point by, let's create an omnidirectional direction by subdividing this current point position by the center. Now as a result, the direction tends to go to the side like this. But maybe you also want to move those direction a bit outward, which goes from center to this point position. So you might also want to add another direction to control the angle of the direction. Now this could be a base direction, but you might also want to have another directional control to make it more stand up, so the tentacle will stand up. I'm not sure if you get what I meant, but let's do it without having first, without having the outward direction, let's try to move the tentacle just with this direction to see how it works. Now I want to normalize this first. Okay. Apply. No errors. Good, good. Okay, so in order to move the point position, I'm going to create a new vector attribute called npos new position, and that is a starting from the current point position plus direction, which is this one, and multiply by value, which is this value, which I've created with the sine function. So if it's close to the endpoint of the line, then it's close to it. The value is equal to 0, close to 0. Then if the point is close to the center of the line, then the value is close to 1. Then finally, you want to have your own multiplier to control the actual lengths. So let's name this offset. Okay. Right. Then finally, you want to update the point position using set point attribute at pt with this new position. Right. Accept, promote this offset value, and let's see how it works. Now I might want to show those base shape as well, and maybe just have the ghosted view like this. Okay, let's see how the curve should move if I change this offset. Okay, it is making a arc-like shape as I want it. Okay. But as you can see, the direction of the curve is a bit to go into a bit too horizontal from what I see. I might also want to add more of a direction goes from the center, the origin of the space, to stand, to make it tilted toward outward. So I might need to have another directional control in order to tilt this curve, in order to control the direction of this curve. So to do that, I'm going to name the first direction direction 1, and I'm going to create another direction called direction 2, which I will call this normalize position minus set 0, 0, 0, which is the center of this ball. And since this is 0, 0, 0, I don't need to subdivide, so I can just do it like this. Now, the final direction that I want to use is direction 1 plus direction 2, and normalize this. And in some case, in order to control the angle gradually, I might want to also have a weight value for direction 1 and direction 2, so that I can control it with more in detail. So let's try to have a parameter like direction 1 multiplier, and multiply this with direction 2 multiplier. Okay. And then by changing those weight value, you can see that I can kind of control the tiltness of this curve, this arch curve. Now I'm gonna set it to 0.5 and 0.5, meaning setting the direction 1, direction 2 weight same, so that it is both affected by both direction in same manner as a default. And I am only going to promote this offset value, which controls the offsetness of this curve, the height of this arch, to this new controller. So let's open this up again. Check off 4-bit linking parameter, then go back to this ring offset, drag and drop this offset. Let's name this link offset. Okay, from 0 to 1. I'm not sure what's the correct range. Let's just keep it 0 to 1 for now. Okay, now after making this, I need to connect the pairs of lines together with either a poly loft node or skin node. I think using the skin node is a good idea in my case, and just using skin node for whole lines doesn't work, so I need to set some conditions. Now the skin node cannot seem to use a attribute, so instead of using attribute, let's set it to groups of n primitive and set it to 2. So by number of 2, it can connect a line with surface like this, and I think this is the correct outlook. Now if you want to use poly loft, you can, I think you can use a attribute value. First of all, let's check this console, check off this connect closest end, and then okay, this might not be useful. Okay, maybe I was wrong. Maybe I cannot use this. Sorry. Maybe it's better to use skin node. Maybe if you want to use poly loft, you might need to use a for each loop as well, which is a bit too cumbersome, so I'm gonna go with skin. Okay. Now after having the skin node, creating the in-between, the tentacle shape like this, I'm going to merge this together with the hexagon and pentagon, which comes out from this second output of the split like this. And as a basic setup, this seems to be good. Now I see some problems with the direction. I mean the direction of the normal of this tentacle. So it is now flipped, so I guess I want to use the reverse right after skin. Okay, now it looks better. And I also want to remove the color from the pentagon, so let's use an attribute delete to delete the color from the primitive. Okay. Right. Now let's use the fuse node to connect all the points. Fuse all points connected. And then try to use a subdivide node to smooth this out, to see the base setup, the base shape, if we have been doing the right thing. Well, it looks close, but not so close. The one thing I need to do here is to able to have a knotted weaving like shape, so this tentacle should go over this, go in between this hole, and this one goes out from this hole. So I should be able to control this tentacle in order to have that kind of intersection, the correct intersection. Let's see if I have enough parameters to do that. If I change this offset value, I might be able to do that, but not enough. Just changing this one doesn't really help. If I change the tiltness of the curve, it might goes a bit better, but still not enough. So to make it, to have more coordination, to have more control over the final shape, let's have some additional parameters in order to control those shapes. Now one thing I could control is the size of the pentagon and the size of the hexagon, and I am already be able to control the size of hexagon by changing this hexagon offset, as you can see like this. But right now the size of the pentagon is fixed. There's no way to control that. So let's add a new parameter in order to control the size of the pentagon right here. Okay, now to do that, I think it's a good idea to do that inside this Pentagon rotation, which is a primitive wrangle filtered by Pentagon group. So I think this is a good good position to add a scale function. Okay, so first of all, let's add a scale parameter, scale, chf scale. Goes from 0 to 1. Then the place where I could add this value is somewhere around here, where I'm doing the transformation. So the scale could be applied right after the rotation or right before the rotation. Either way should work. Let's do that right after the rotation. I'll multiply the position by the scale value, scale parameter. Now I am able to control the shape of this pentagon by changing this scale value. Right, looks good. Let's have this promoted inside this controller again. Okay, let's open up the edit parameter interface. Uncheck for bit linking, and go back to the pentagon primitive wrangle, drag and drop this scale somewhere close to the hexagon offset value. I'm going to name this Pentagon scale. From 0 to 1 is fine. Okay. What else could there be for additional parameters? Let's think. Another things that I could think of is an offset the position of the hexagon. If you look at the photo of the final product, you could see that the hexagon, the place where hexagon should be, is a bit offset inside compared to the pentagon positions. So I might, and at this moment the position of the hexagon is kind of at the same radius as the pentagon, so I might want to move the position of the hexagon just a bit more inward, close to the center of this ball. So let's try to add a parameter in order to control this position of the hexagon. And I guess I can do that inside this hex rotation primitive wrangle, which I'm controlling the hexagon's rotation. Since this is filtering the hexagon, the small hexagon value, hexagon shape, I could just add offset value as well, offset function as well, transformation as well inside this primitive wrangle. Okay, let's open up and let's add some parameter in order to control the offset. So let's name this hex offset. That's the same name as I have in the null controller right now. Let's name this hex distance. Not a perfect name, but you'll get it. Okay, apply, promote. Let's have some value here, and let's use this value in order to move the hexagon inward. So where I could do that, I could do this transformation where I'm controlling the point position, which should be somewhere around here. I'm rotating the point of the hexagon right here. So same for the scale. I could add a transformation to these steps. Now for the moving part, I could do it right after I have moved back this point position with the center point position. I mean, I could also do that in between the rotation and the final step. Either way should work. Now the offset value that I want to use is, what's the name? Hex distance. So hex dist, and the direction where I want to move is negative normal direction. Okay, so this should be it. Accept. Now let's see how it works. If I move this, can you see that this is the hexagon shape, and can you see that this shape is going inward if I increase the value hex distance? Yeah, seems to work. Seems to work, I think. Right. Okay, now let's have this parameter promoted in the null controller again. And let's check off orbit linking and go back to the, where was it, hex rotation, drag and drop hex distance, and put it somewhere around here. So hexagon distance. Right. Okay, now I have several parameters right now to control the shape, the base shape. And let's see, these are enough to control. to have kind of intersection, and this seems to work well. So yeah, this is kind of the shape that I want to have as a final step, which have arch intersecting, looping each other, weaving each other like this. And this is a good setup. I think this is a good parameter to go with, but I want to keep this angle 60 actually. So let's see if I could keep this value 60 and if I could use other parameters to control these to have a weaving pattern around here. And currently I don't think I'd be able to do that. I think I need some more parameters. And what if I change this tilt? Maybe not. Okay, let's set this to 0.5 and 0.5. So I'm going to give one more parameter, one last parameter in order to control the total base shape. That is how much the arch will change based on the t value that I have created before, that I have retrieved from the curve view here. So currently I have t like this, but which was a continuous linear value, which was like this line. But if I change this base curve view value to something like this or this, then after I have converting this value into an angle for the sine angle, then the final output of the sine wave should also deform like somewhere like this or like this. So let's try to have that kind of let's try to deform this linear line into something like this or something like this using power function. To do that, that is pretty easy. After the t, I'm going to update this t using a power function with some parameters power. Okay, now let's try to change this power value, promoting this value, and if I change this, I can see that the shape of the curve is changing based on the value of this power. If I increase it more, you can see that the shape is changing. Now let's try to keep it as 0.5 and try to find the right position for the other shapes in order to create a weaving pattern. Now, do I have it? Maybe not. Maybe I might need to rotate this after all. Yeah. Let me first check the final one if I have enough parameters. Okay, so I have a ring offset value and Pentagon scale, Pentagon offset, Hexagon distance, rotation angle, Where is the power? Yeah, the power is right here. I haven't promoted yet. Alright, I am not sure if this is a good value to go or not. I might be missing something here. Maybe there isn't enough parameter yet, but let's try to go with this for now. Okay, let's also cancel this subdivide, and let's also try to... Now I cannot really see if this is a good value or not yet, because this doesn't have any thickness yet. So let's have some thickness value in order to control, in order to actually see the final outlook from this basic shape. Alright, so to do that, first thing I would like to do is to create a poly extrude. And check the output back. Then let's control the distance like this. Now after doing this, I'm going to connect this subdivide to smooth this out. Like this. Say 2 or 3. Right? And if you want to have a sharp edge at the side, you might also want to raise this division value to something like 3 to 4. And if you hide those ridge lines, you have this base shape made with 3D thickness. Now let's try to find out some right parameters for this one. Starting with hexagon distance to be a bit closer, somewhere right here. The offset to be 1/8. And the ring offset to be somewhere around here. Pentagon rotation axis. Pentagon rotation angle 90 degrees. Now this doesn't really look like the shape I want to have, actually. I think I'm missing something. Let's see. Let me go from the start. So I've started from here. I have this bowl. I'm checking with the final setup I have created. And for the hexagonal rotation, I have a shape like this. Okay, I think I am kind of missing something here. probably. I am controlling the offset right here. Okay, I think one more thing that I was missing is this. Oh wait, but I already have it here. Okay, so I am also controlling the inward value, which is currently 0.15. Let me change this to 0.18. Okay. Now, so far it looks the same as the one that I have created for the final output. Okay. And for this angle, 60 degree, using 60 degrees as default value is also the same. And for the offset, I was using 0.23, which is pretty much the same. Now for the penta rotation, I'm setting the scale to positive 0.9, right? And anything else? For the rotation, I think I'm setting it to -72, which is same as the one I have done, I think. Right. And when I have created the shape like this, the tentacle shape. Okay, this might be different. This might be wrong. Okay, let me check this ring offset function. Okay, well, sorry for that. I am not sure where I did it wrong. Okay, let me check. Okay, I think I have to set. Right now I'm using t, which goes from 0 to 1, but I might have to think that t goes from 1 to 0. So let's try to change this t value by subdividing this with 1.0. Now I see some nicer form. Okay, let's go back to the final connection. Okay, now I think it seems to have a much better shape right here. Okay, and when I extrude it, still looks good. Subdivide it, yeah. Okay, so that was the place that I have to correct right here. Okay. Now if I change those parameters, oops. I should be able to control the shape more in better shape. Okay, let's add several parameters. First of all, let's add the parameter in order to control the thickness. Let's go back here, poly extrude. So I want to control this value with the parameter. So go back to the controller. Add a thickness value. Let's set it to 0 to 1. And also let's also add extrude division value in order to control the softness or hardness of the side. I'll name this hardness. The range between 1 to something like 4. So if it's 1 equal to 1, it's really soft. The side is soft. If it's 4, you have more hard edge. So let's copy this thickness value, go back to the poly extrude, paste it right here. And for the division, let's paste it right here and rename this to hardness. Okay. Alright, let's try to control the value. If I control the thickness, yeah, it's working. And if I try to control the hardness, you can control the side hardness right like this. Okay. Another thing I want to parameterize is the power value that I have created here. Right. I think this also works well. Yeah. So let's bring this power value to the null node right after ring offset. So I'll name this ring curve power or something. Okay, I have to check off this 4-bit linking parameter, then bring this power ring. I'll just name ring power from 0 to 1. Yeah. Okay. Now one last thing I would like to do. Currently, if you look at this carefully, you can see that the top part of this pentagon is a bit too flat. So I want to make it a bit more round. To do that, I am missing some center point right here. I might want to add one more point right here, which is around here, to create more like a bowl-like shape and create split this pentagon into a bunch of triangles. So that will be the last thing I would like to do for this shape, and that's the final. Okay. Now it is not really necessary, but I just want to do that to make it a bit more prettier. So I'm gonna do it inside this pentagon rotation wrangle right here. And to do that, I am going to first of all, let's create a center point, which should be just around this point, and you can estimate this position by one of the point on the pentagon, by the distance from this point to the center of the bowl which is 0, 0, 0. So use that length to move the center point of the hexagon to outward so that the point aligns on top of the same sphere. Okay. I'm not sure if you got what I mean, but first of all, let's get the center of the center of the pentagon, penta P by point at P. Yeah, this is just at P. And the length of one of the point on the pentagon can be calculated by T. First I'm just going to get one of the point from the pentagon using P from one of the point on the inside of PTS. I'm just gonna get the first point, 0, like this, and then I want to get the length of this position from the center point, which can be calculated like this, retrieved like this. And the final center position that I want to create is at the direction to this penta P multiplied by the length that I have found out. Okay, I do see some point created right here, so let's use this point to reconstruct this pentagon as it is aligning projected to the sphere. Okay, I could do that inside this for loop, since the number of triangles is equal to the number of points, so I could just directly use this for loop to create a necessary triangle. Okay, so right after I have set the new point position, I'm going to get point 2, which is next to the previous point. So if I'm looking at this point, then I want to look at the next point of the pentagon, and I could do that by PTS I plus 1, and if it's more than length of the PTS, then I could calculate the modulus like this, so that if the value is equal to length of the PTS, it will reset to 0. Right, and let's create a triangle using add prim, poly, starting from center, PT and PT2. Okay, now I have this triangle created, and I don't need the underneath pentagon anymore, so let's remove that using remove prim. Oops, like this. Let's check the edge. Yep, it has now been reconstructed with triangles. Okay, now let's look at the final shape. Going back to the final. Now it became more smooth. Great. Looking great. Looking great. Yeah. So this is the final shape that I wanted to create. Now after this, you can try to change those parameters you have set to try out different shapes with different parameters. You'll be able to find out different kinds of shapes, different kind of interesting shape. sometimes it intersect to each other, so you might want to careful. You want to be able you might want to control it by looking at the display closely. But at some point you'll be able to find a value, find a parameter where it doesn't intersect. Well, it still does, but I guess there's some. Yeah, this seems to work. Now this also looks interesting, and this is a whole continuous single shape, and which means that you can also 3D print it to create this one interesting shape. Alright, so the example shows how to color this by the distance from the center, but I'm gonna skip that part for this tutorial. It's just gonna take too much time. But if you look at the example file, you'll see how I'm doing. It's not that hard to do. Okay, so I have a question. How long did it take you before you felt this comfortable with Vex? Well, I'm not still comfortable with Vex yet. I'm still trying to get used to this. But I found it fun to use as soon as I started using it. But it did take some time, like 2 to 3 months, to know the function that I could use. So at that time I was going back and forth the document, the reference page for the Vex functions in the side effects website. So every time I tried to do new things, I always had to look at those reference pages if there is a function that I am looking for or not. And a lot of time I wasn't able to find what was I looking for, so what I wanted to use. So I went to like forum like Outforce to ask questions, and everybody was like kind enough to answer my questions. So I guess that's how I get used to using Vex. And I guess after 3 months of using it, I was a bit more comfortable using Vex without seeing much function pages, reference pages. But I do still check reference pages a lot, even nowadays, because there are tons of functions that I haven't even used it at least once. But yeah, I guess I kind of get the essential functions at this moment, especially for controlling the vectors and some of the matrix. I'm still not like good at controlling the matrix yet. I want to do that. I want to be able to get more comfortable using the matrix as well, also the quaternion. But for vectors, I think I'm pretty confident using it. How to control vectors. So I guess that's the way to go with the vex. To master the vectors means also mastering the vex as well. Probably, I'm not sure. Well, I hope you find this out interesting. Well, I myself really like this kind of shape, so I do want to try out printing this with some material using 3D printing. This should be really nice. And since this is a Houdini procedural modeling tool, you can apply a whole lot of additional stuff on top of this geometry right after this one, like creating the Voronoi holes to it or something like that procedurally, which makes it even more interesting, I think. So I hope you would try that out for yourself. For today, I just showed how to create the base shape parametrically. This is also interesting. Okay, well, thank you very much for people who have joined me through until this time. It took like more than 2 hours. Yeah, it was really long. Sorry for that. Okay. Oh, thank you very much. And I'm planning to do the live streaming for next week on same time as well. So if you're interested, please consider joining. Okay. That's all for today. And thank you very much. Okay, so I will end the live stream. Yeah, I also want to create new types of geometry. Yeah, my inspiration always comes from other person's work, so it's kind of a, how do I say, decompiling or disassembling kind of stuff, reverse engineering. My style is something like that. So since I'm not really an artist, I'm more like a bit more toward the logical thinking stuff, I guess. Alright. Well, I hope to see you all next week. You can download the file from the description in this video. Please use it as freely as however you want. And if you have made some new additions, maybe if you could show me that, I'll be really happy. Right. Thank you. Bye.